Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, in this lecture, I want to discuss some standard differential equation that is of second order with constant coefficient. So I want to discuss in detail how we can find the solution of some standard differential equation. So we are given here some standard differential equation. There are 6 differential equations which are in standard form. So in all 6 differential equation of second order with constant coefficient, we apply same procedure. If you understand one problem clearly, then you can solve every problem in same time. There will be no problem to solve other problem. So I want to discuss here first problem, how we can solve this problem with the help of method y is equal to Cf plus Pi. We apply in this equation. Complete solution is y is equal to Cf plus Pi. Y is dependent variable, x is independent variable, y is dependent on x. So y is equal to Cf plus Pi is there. So now, we discuss these standard differential equation solving in case 10. Already we have discussed case 9. From 1 to case 9, we have discussed in ordinary linear differential equation with constant coefficient. So these differential equations solved one by one case, and now we have completed 9 cases. Today I want to discuss case 10. In case 10, we are solving here some standard differential equation. So in case 10, in this case, I want to discuss about the solution of some standard differential equations which are given as follows. Here I am writing some differential equations. These differential equations are known as a standard form. There are 6 equations are there. So all equations have same procedure to finding solution. So now first equation is solve d2y over dx2. This is the second derivative. One is multiply with this derivative and plus a square y equal to 10ax. Or means athva. Otherwise, we can write this equation 1 in second form. Second form is d square plus a square y equal to 10ax. This is d form. This equation, second equation is d form, mean function is d. This equation write in function d into y equal to 10ax. So this is function d. Function d, what is function d here? Function d is d square plus a square. This is function d. fd means function d here. This is function d. So this is given standard equation. Now other equations, same equation, same. Here q is change. In these equations, value of q is change. Here q is 10ax. Q is here 10ax given in our equation 10ax. Okay. Now problem 2, solve d2y over dx2 plus a square y equal to sec ax. This is second problem. Or we can write this problem 2 in d square plus a square y equal to sec ax. Here q is sec ax. Now next problem, problem 3, d2y over dx2 plus a square y equal to cosec ax. Here q is cosec ax. Or d square plus a square y equal to cosec ax. This is d form. Similarly, problem 4, d2y over dx2 plus a square y equal to cot AX. Here Q is given cot AX. Cot AX is given. Or D square plus A square Y equal to cot AX. Now next problem 5. D2y over dx2 plus A square Y equal to sin AX. So here Q is sin AX. Sin AX is given here. Or athwa we can write this problem 5 in this type. This is D form equation. So D square plus A square Y equal to sin AX. Last problem of this topic is D2y over dx2 plus A square Y equal to cos AX. Or we can write D square plus A square Y equal to cos AX. Here Q is equal to cos AX. Okay. So there are 6 problems which are in standard form, and the procedure to finding the solution of all 6 problems have same procedure. Every step is same in all equations. So now we want to solve first problem with the help of method y is equal to CF plus PI. So here we can solve all equation 1 to 6. Here I am telling you clearly, we can solve all equations 1 to 6 by same procedure. No other procedure is applied here. In all equations solved by same procedure. So here we see that left hand side of all equations, equation 1, 2, 3, 4, 5 and 6 are same. What is left hand side here? D square plus A square Y equal to 0. If we are putting Q equal to 0 in all standard equations, then we find that left hand side of all equations are same. So what is left hand side? Left hand side is D square plus A square Y equal to 0. Here taking Q equal to 0. After taking Q equal to 0, in each equation we get left hand side is this D square plus A square Y equal to 0. So all equations have the same complementary function if we are taking Q equal to 0, and left hand side is same of all equations. So we can say that complementary functions is equal of all equations. So problem 1 here based on case 10. So I want to discuss a problem, completely solution of problem on case 10. So there are given 6 problem. Out of 6, here some problem we want to solve, and other problem same procedure apply, solve by the student self. So here problem 1. This is problem 1. Problem 1 based on case 10. So I am taking here first problem, d2y over dx2 plus a square y equal to 10ax. How we can say that this is the linear differential equation of second order with constant coefficient? How we can say? So we see that in left hand side of the differential equation, here is one number. This is second derivative. Here is one number. Here first derivative is not there. So the coefficient of first derivative is 0. So first derivative is not present. If any derivative, the coefficient is 0, then that derivative is not present there. That is 0. And plus a square y. A square is a number which is multiplied with y here. So we see that in this equation in left hand side, the numbers are in multiply with derivatives and with function. So in left hand side is all numbers are there. So we can say that this is the linear differential equation of second order with constant coefficient. But in right hand side is some function, that is fx, some function of x. So that is q. Here this is q. Q is given here 10ax. In our question is 10ax. 10ax is given. Or this equation can be write in this form: d square plus a square y equal to 10ax. Because general equation of our question is given in the form of fd into y is equal to q. This is the general form of the question. fd y is equal to q. So now here solution start of problem 1. So problem 1 is d2y over dx2 plus a square y equal to 10ax. This is equation 1. This is given in our question paper. Then first we write solution and then we write the given question in our question paper. So we write this question, that is equation 1 first. This equation 1 is given in our question paper. So I want to solve this equation 1. And this equation 1 is known as a linear differential equation with constant coefficient. And this is known as a standard form because there are all 6 questions in same type. So we can say this is standard form equation. So equation 1 can be written as, this is D form equation. Here d2 over dx2. I am telling several times. This result is d square. And d, so I am writing here d2y over dx2 and plus a square y equal to 10ax. So now this is d square y and plus a square y equal to 10ax. So here y is common. So d square plus a square and y taking common. Y here taking right hand side common. Because y is differentiable. Y is the function. Y is differentiable in our differential equation. So we take y common to the right hand side. If you are taking to the left hand side, then your question is wrong 100%. So function taking to the right hand side common equal to 10ax. So this equation is second type. This equation number 2. We can write equation 1 in equation 2. Now in equation 2, in our general equation is this given: f dy is equal to q. F dy is equal to q, where q equal to 10ax. This is equation 3, where fd, what is fd here? Fd is d square plus a square. Fd, value of fd is d square plus a square. This is equation 4. Solution of equation 2 in 2 parts. In last lectures we have discussed then a linear differential equation with constant coefficient. Then the solution of this differential equation always we get in 2 parts. First part is complementary function and other part is particular integral. So here, because q is given here, particular integral, we find particular integral when q is given. If q is not given, then we find only complementary function. Particular integral 0 if q is 0. So first solution is CF. And second one is pi. So now here first we will find complementary function of given differential equation. So to find CF, putting q equal to 0. Finding CF if q is given, and we want to find the CF complementary function, then q putting must equal to 0. Q taking as a 0 for some time. For finding complementary function, putting q is 0 here in equation 2. Then we get here our equation convert into equation 5. D square plus a square y equal to 0. This is D form. Function D. This is function is D. Function D equal to here D square plus a square. This is FD. Derivative form. Equation is in derivative form. So now in 5 putting D equal to 5 and removing y from 5. In this equation we want to convert equation 5 in an algebraic form, an algebraic equation. So putting D equal to m. M is number. So D equal to putting m. How we can putting here d equal to m. This is discussed in last lectures in detail. So now here putting d equal to m and removing y from the question. So now in 5 putting d equal to m and removing y from 5. Then we get an auxiliary form of 5. This 5 convert in auxiliary form. So what is auxiliary form? M square plus a square equal to 0. This is equation 6. So m square equal to here minus a square. This a square plus a square taking to right hand side. Right hand side already there 0. So 0 minus a square. So here is minus a square. This equal to minus means minus 1. Any place minus 1, minus a square means minus 1 into a square. And minus 1, I square is minus 1 here. I is imaginary number and the square of any imaginary number, square of any imaginary number I square equal to minus 1. I is imaginary number, not any. I is specially denote the imaginary number. So this is I square minus 1 putting here. So m square equal to I square a square. Now m equal to plus minus ai. We are taking this solution of this m square minus I square. So I am taking solution like this. M square equal to I square and a square. Okay. So m square minus I square into a square equal to 0. So this is m square minus I into a ka whole square equal to 0. Formula here apply a square minus b square equal to a plus b and a minus b. So here m plus ai and into m minus ai equal to 0. So if m equal to m plus ai is 0, then m equal to minus ai and m minus ai is 0, then this implied that m equal to ai. So we get here two roots, m equal to here m1 that is ai and m equal to m2 that is minus ai. So there are two roots. So one is plus roots, other is negative roots. So b value is same in both roots, value is same, but one roots is positive and other roots is negative. So b can say plus minus. So m equal to here plus minus ai. Roots are imaginary here because I is present here. I is iota. I is here root minus 1. I is the value of root minus 1. This is root minus 1 is an imaginary number. So here we get roots of an auxiliary form of 6. So we apply here formula for imaginary roots. Formula for complementary function if roots are imaginary. So here m equal to here plus minus ai. M equal to this roots is as this form alpha plus minus I beta. So here comparing this one, so alpha is here 0 and beta equal to I. Beta equal to a. Beta is a. So now formula for imaginary roots of complementary function. Complementary function. So this is the formula for CF here. CF equal to e to the power alpha x, C1 cos beta x plus C2 sin beta x. This is equation number 7. Now putting value of alpha and beta in equation 7, then we get CF. So CF is equal to e to the power alpha. Alpha is 0. This is the value of alpha. Alpha is 0 and beta is a. So e to the power 0x, C1 cos ax plus C2 sin ax. So CF is equal to, this is 1. E to the power 0x, this is 1. So here C1 cos ax plus C2 sin ax. This is complete CF. Equation 8 is complete CF of 1. So I am already discussed that left hand side of given each differential equation is same. So complementary function of every equation is same. So this is the answer of each equation. This is the complementary function of each equation. Equation 8 is complete CF of 1. Now we will find PI, particular integral of 1. So we apply formula here of particular integral. We apply here formula for particular integral. So this is the particular integral equal to 1 upon FD into Q. This is basic formula. We apply in several questions. So this equal to 1 upon FD. I am already discussed FD is, here FD is D square plus A square. This is value of FD. I am already discussed here. So putting the value of FD here and Q. Q is 10AX. In our question, Q is 10AX. 10AX given in our question. So here I am putting here 1 upon D square plus A square. This is FD and into 10AX. This is equation 9. So now 1 upon D square. This is PI. This side is PI, particular integral, PI. This is PI and this is PI, particular integral. So PI equal to 1 upon D square plus A square 10AX. Now 1 upon D square. Here is plus sign. So I am writing minus and minus 1. Minus and minus 1, minus minus plus. So minus 1A square 10AX. 1 upon D square minus minus 1A square here. So I square is minus 1. Minus 1 is I square. So I am writing here I square A square. So this is A, here formula apply A square minus B square. So this equal to A plus B and A minus B. I am applying this formula here. So here D plus IA and D minus IA. Because here D square minus I square and A square. So this is D ka square minus I A ka square. So this equal to here D plus IA and into D minus IA. This is factorization of this result. So I am writing here factor. This is IA this. Okay. Into 10AX. This is Q. This is the value of Q. Now breaking by partial fraction to equation 10. In equation 10, there are two factors here. So we apply here partial fraction. How we can apply here partial fraction? So here is formula of partial fraction. 1 upon x plus a and x minus a. So we apply here a upon x plus a and plus b upon x minus a. So for finding x, for finding a, putting x plus a equal to 0. So x equal to minus a, I am putting here. So this side is 1 equal to a, x minus a and plus b, x plus a. And denominator is cancelled. So putting x equal to minus a, 1, x equal to minus a. So here is minus 2a and into a. So a equal to here minus 1 upon 2a. This is value of a. And next putting for v x minus a equal to 0, then x equal to a. So 1 equal to here, this result is 0. When putting this is x plus a. So putting a 2a into b, then v equal to here 1 upon 2a. These value putting here a and b, we get the partial fraction complete here. So we write here same result we apply here direct. So here d minus ia, d plus ia. After taking LCM, this goes to this side, d plus ia. And this goes to this side, this goes to this side. So here is minus d plus ia. And upon is multiplied to this. So this dd is cancelled. So this is 2ia. And divide by 2ia here. So this is the partial fraction here. Now breaking by partial fraction to equation 10. We can break this directly. It is very easy function. So we can write directly this function. So here is ia. This is I. So now 1 upon 2ia t minus ia multiply by 10ax. Inside the bracket in both function, both derivatives, we multiply by this function. 1 upon d minus ia 10ax and minus 1 upon d plus IA 10ax. So we are considering this first function phi1 and second function is phi2. So I am writing here phi1 and phi2. This equation 12. So this 12 is equation 12 is complete particular integral of equation 1. Here we find out the value of phi1 and phi2 one by one. Then when we get the complete phi1 and phi2 and putting in 12, equation 12, then we get complete pi. So equation 12 is complete pi of 1, where 1 upon d minus ia. What is d minus ia? D minus ia into 10x equal to phi1. I am considering this let or consider this. Let this equal to this and let this both value I am let 1 upon d plus ia 10ax equal to phi2. This equation 13, this equation 14. Here we will find the value of phi1 and phi2 from equation 13 and 14. After solving equation 13 and solving equation 14, then we find value of phi1 and phi2. Solving equation 13 first. First we want to solve equation 13. Then we get phi1, value of phi1 we get here. So we have d minus ia 10ax equal to phi1, this equation 13. So d minus ia here. D minus ia, this is I here. D minus ia into phi1 equal to 10x. Here cross multiplying this. This is cross multiplying. This term goes to with phi1, here is 1. So multiply here, cross multiply. In equation 13, we are taking cross multiplication. So this 10x in numerator, this is in denominator, this is phi1 and denominator is 1. So 1 multiply by 10ax and phi1 multiply d minus ia. Then we write this one is d minus ia phi1 equal to 10ax. This is equation 15. So here d multiply phi1 inside the bracket. So d phi1 minus a phi1. Here is ia. I. Here ia phi1 equal to 10ax. This equation 15. Where d, what is d? D is d over dx. D is here d over dx differentiating with respect to x here. This is the value of d. So d phi1 upon d, putting the value of d, this value putting here, d over dx of phi1 minus ia, this is I. This is correct. ia phi1 equal to 10ax. This is equation 16. We see that equation 16 is a linear differential equation of first order and first degree, because this is a linear differential equation. So what is linear differential equation? What is general equation of linear differential equation? So first we know about the linear differential equation of first order and first degree. So I am given here, we know that dy dx plus py is equal to q. If you don't know about this differential equation, then you cannot solve this problem, because this is the helpful formula in our question. So dy dx plus py equal to q. This is known as a general linear differential equation of first order and first degree. This equation 17. Here p is multiplied with y. Q is the right hand side here. So now this is general linear differential equation 17. Linear differential equation. Comparing 17 and 16. Here comparing equation 17 and equation 16 and equation 16. Comparing equation 17 and equation 16. Then we get p equal to minus ia. What is p here? P is minus ia and q is 10ax. So now if, first of all we find out the if integrating factor to solve a linear differential equation, because our 16 equation is known as a linear differential equation of first order and first degree. So we apply the formula of general linear differential equation of first order and first degree to find the solution of phi1. So here comparing equation 16 with general linear differential equation. Then we get value of P and Q. P and Q is given in our general linear differential equation of first order and first degree. So P is here minus AI and Q is here 10AX. So first of all, we find here IF, integrating factor IF. IF is e to the power integral P dx. This is formula of integrating factor. When we have discussed a linear differential equation of first order and first degree, then we proved this formula. This formula already we have proved in our lecture. So IF is e to the power integral P dx, e to the power integral P. P is here I. Here is e to the power integral minus AI dx. So here is AI. AX, IAX. So, but this is IF is e to the power minus IAX. In next, here we apply the formula. This is formula for linear differential equation. General formula for finding the solution of linear differential equation of first order and first degree. So this is solution formula of linear differential equation. Putting value of integrating factor here and Q. Both value I am putting here in this formula. I have already proved this formula in last lectures, when we have discussed about linear differential equation with constant Coeff, with linear differential equation with first order and first degree. Then we proved this formula, y into IF integrating factor equal to integration Q into IF dx. So here we are finding the particular integral, so we are not adding here constant. So here y is phi1, y is our function in general equation, but in our equation is phi1 is function. E to the power minus IAX, here is IAX, this is I, minus IAX, and equal to, this is Q, Q is 10AX, and e to the power IAX this, and dx. So now, phi1 e to the power minus IAX equal to formula for 10AX. 10AX formula is sin AX upon cos AX. Sin AX upon cos AX. This is formula of 10AX. In trigonometrical formula, we can break off 10AX in sin and cosine. Then we get formula of 10AX equal to sin AX upon cos AX. So I am writing here formula of 10AX this. And e to the power minus IAX. So e to the power minus IAX, formula of this cos AX minus I sin AX. So this is formula here. So I am writing here I sin AX. And bracket close, this is dx. So this is equation number 18. Now solving equation 18 completely. How we can solve here 18? So I am discussing here in detail about the solution of equation 18. So this is phi1 e to the power minus IAX equal to, this is sin AX upon cos AX, break off 10AX. I am breaking off 10AX here. 10AX equal to sin AX upon cos AX. This is break of 10AX. So I am putting this formula here. This is the value of e to the power IAX. E to the power IAX minus this equal to cos AX minus I sin AX. So here is I there. I sin AX dx. So now multiply by this function 2 in bracket. Then we see that cos is cancelled. So we get only here sin AX. And multiply here. So minus I into sin square AX. Sin AX into sin AX. This sin AX into sin AX. Sin square AX upon cos AX. Okay, dx. Phi1 e to the power minus IAX equal to integration sin AX minus I. Sin square AX, I am writing here formula. Sin square AX is equal to 1 minus cos square ax. This is formula. This formula I am writing here upon cos ax dx. So now multiply by this separate function sin ax dx. This dx differentiating with integrating with respect to x. So integrating each function in this integral. So first function is sin ax dx, multiply minus I 1 upon cos, here 1 upon cos ax, 1 upon cos ax, this equal to sec ax. So I am writing here sec ax dx and cos square upon cos ax. Next is cos square ax upon cos ax. So 1 cos ax is cancelled. So we get here only cos ax. So sec ax dx, here is I, minus I, here is I, and here is also minus plus I. So now next phi 1 e to the power minus I x equal to minus 1 upon a. Minus क्यों? Why here we get minus integration of sin ax. Integration of sin ax is minus cos ax upon a. So here write integration of sin ax dx, this is dx, this equal to minus 1 upon a cos ax. This is formula. Sin ax dx equal to minus 1 upon a cos ax. So I am writing this answer here. Next one is integration of sec ax minus I. Minus I integration of sec ax. So I am writing here integration of sec ax. Integration of sec ax dx. So answer is 1 upon a and log sec ax plus tan ax. Sec ax plus tan ax. This is integration. Log sec ax plus tan ax. This is log. Log sec ax plus tan ax. So I am writing here formula minus 1 upon a log sec ax plus tan ax. And next one is integration of cos ax. Cos ax 1 upon a sin ax. Integration. Integration of cos ax dx. This is equal to 1 upon a sin ax. This is integration. So all formula we showing here apply in this equation 80. So here is I sin ax. Here is I sin ax I upon a sin ax. So this minus and this plus. Minus plus. So minus 1 upon a cos ax. So dividing by this function in right hand side. E to the power minus ix dividing to right hand side. If we dividing minus sign, then this goes in denominator. Then denominator after writing in numerator, that is plus positive. So here I am writing minus 1 upon a cos ax e to the power plus ix and minus I upon a log sec ax plus tan ax e to the power plus ix. Why there plus ix? Be dividing by this function. This is e to the power minus ix in left hand side with phi 1. So divide here we want only phi 1. So eliminating here, remove from here this side. So dividing by e to the power minus ix on both sides. Then we get. So after dividing this, we get here plus e to the power ix, plus e to the power ix, and here is also plus e to the power ix. Okay. So now this equation 19. This is complete value of phi 1. This is complete value of complete value of phi 1. We get this value of phi 1 here. Now solving equation 14. This is the solution of equation 30. And now next phi 2. Phi 2 is the 14 equation. So we solve equation next phi 2. Same procedure. There will be no change any line. Only plus minus is change here. Function is also not change in each step. So now I am telling you 1 upon d plus ia tan ax equal to phi 2. This equation 14. 13 and 14. 13 which is given in phi 1 and 14 given in phi 2. So when we solve equation 13, then we get phi 1. Now I I am solving equation 14, then we get phi 2, value of phi 2. So here 1 upon d plus IA tan AX equal to phi 2, this equation 14. So here is 1 and cross multiply here. After cross multiply A upon V equal to C upon D. So this is cross multiply. So this is tan AX is A, this is V, this is C and D is 1. Then we get this equation. Equation is 20. Now, here phi 2 multiply in bracket, phi 2 taking inside the bracket, d phi 2 minus IA plus IA phi 2. So I am writing here d phi 2 plus IA phi 2 equal to tan AX. This is equation 15, where d is d by dx. D is differentiation with respect to x here, capital D. So now putting this value in this equation, then we find d phi 2 upon dx plus IA phi 2 equal to tan AX. This is equation 16. Again 16 equation is a linear differential equation. This is linear differential equation of first order and first degree. So this is same problem, is general problem is this. So we know that this is general equation of linear differential equation with first order and first degree. So equation 70. This is general linear differential equation. After comparing 16 and 17, then we get P and Q here. Comparing this one, this is d phi 2 over dx plus IA phi 2 equal to tan AX. Okay, and general equation is d by dx plus Py is equal to Q. So this is y function. In this equation is y function, but here is phi 2 function. So here same equation. So P is IA and Q is tan AX. So I am writing here P is IA and Q is tan AX. So now finding integrating factor. Finding integrating factor. Integrating factor. That is known as a IF. Short form we can say this IF. So formula of IF, e to the power integral P dx. E to the power integral P. P means IA dx. IA dx. This is I. So now e to the power IAX. IA is constant taking out and integral of 1 here. Here e to the power. Here is IA dx. IA dx. IA is constant and integration here 1 dx. So this is the power of E. So here is e to the power, this is IA. So IAX, this is integration. So now here apply formula for solution of linear differential equation of first order and first degree. So this is general formula we apply in every linear differential equation to find the solution. So here y into IF is equal to Q into IF dx. This is solution. This is solution of d by dx plus Py is equal to Q. This is solution of this differential equation. Formula of linear differential equation. Putting value of integrating factor in this formula. Putting value of integrating factor and Q and Y. Y is here phi 2. So now here Y is phi 2. Integrating factor e to the power IAX. Integration tan AX e to the power IX. This is IF and dx. So now putting the value of tan AX. Tan AX again. This equal to sin AX upon cos AX. So I am writing this function e to the power IAX cos AX plus I sin AX. This is dx. This is equation number 21. Now after solution this, now solving 21. So phi 2 e to the power IAX sin AX upon cos AX and cos AX plus I sin AX dx. So multiply by this function to this and to this. If multiply by first function, then this cancel. So we get here sin ax only. And this multiply here, so sin square ax upon cos ax dx. So phi 2 e to the power I ax equal to, separate the function sin ax plus I. Here sin square ax. I am writing formula sin square ax is equal to 1 minus cos square ax. This formula apply here. So I am writing here formula this 1 minus cos square ax upon cos ax dx. So now breaking this result, multiply by dx sin ax dx, and here is plus I 1 upon cos ax. 1 upon cos ax equal to, that is sec ax formula. So I am writing here sec ax, and here this upon this, then 1 cos is cancel this. So we get here cos ax dx, and I is also here, I is multiplied by I. So now here phi 2 e to the power I ax minus 1 upon a cos ax. We apply here integration of sin ax, this equal to minus 1 upon a and cos ax. And here next function is here integration sec ax. So integration, again I am writing formula integration sec ax. So integration 1 upon a log sec ax and plus tan ax. This is formula. This equal to 1 upon a and log sec ax plus tan ax. This is integration of sec ax. Okay, sec ax dx. This is sin ax dx. So now here I am writing formula 1 upon a log sec ax plus tan ax, and this is integration of cos ax. Cos ax 1 upon a sin ax. Integration of cos ax and dx equal to 1 upon a sin ax. So I am writing here formula, all value putting here, dividing by this e to the power ix, taking right hand side. So divide by this formula, this goes to denominator, then we write in numerator. Then denominator is plus, in numerator is minus. So I am writing here minus e to the power minus ix upon a cos ax. E to the power minus ix, this is I here, minus ix upon a log sec ax plus tan ax. Minus I here, plus minus plus minus, minus plus minus sign. In first solution minus minus plus. Here is minus, plus and minus. So here log sec ax plus tan ax. Here again negative this e to the power minus ix. First of all this goes to denominator. Positive goes to denominator. Then we write in numerator. Then sign change. Then we write here minus ix upon sin ax. This is equation 23. This is value of phi 2. This is complete solution of 14 equation 14. So here we get, after solving equation 13 and 14, we get value of phi 1 and phi 2. So now these value phi 1 and phi 2 putting in equation 12. Then we get complete pi. So now putting value of phi 1 and phi 2 from equation 19 and 23. 19 is complete solution of phi 1 and 23 is complete solution of phi 2. Putting in equation 12. So what is equation 12? Equation 12 is this given here. 1 upon 2ia phi 1 minus phi 2. Now putting value of first phi 1 here. Phi 1 is minus, minus, plus. So here minus 1 upon a cos ax e to the power plus I. Here is plus. Because this side is negative. Then we divided by negative. That is converted into in positive. So minus I 1 upon a log sec ax plus tan ax e to the power ix. And I 1 upon a sin ax e to the power plus ix. This is plus. Similarly minus, this is the value of phi 2. Minus plus minus, minus e to the power ix. This is plus. And here this plus. And here this plus. Here is minus. All terms are minus here. First is e to the power phi 1. Phi 1 is, in phi 1 is positive and phi2 is negative. Okay. Here is phi1 is negative. This is negative sign. And this is also negative, because here is negative, then negative goes to positive and positive goes to negative. So here is positive. This is positive. All positive here. Okay. Here is negative sign. This negative, and this negative. Okay. So now here next. Here 1 upon a. What happened here? Direct I am writing here. Just I am this one. So now this equal to 1 upon a is common in this bracket. A is common. And e to the power here cos ax. In this is cos ax and cos ax here. This is minus sign and this is minus plus. So I am taking here minus sign is common. This equal to minus. So here cos ax is common. Cos ax. And here bracket e to the power iax. This is plus. Minus taking common. Then this function is plus. And this minus plus. So this is minus. E to the power minus iax. And here is 2ia. So a is this. 2ia. 2i taking here. And 1 upon a. Here is a square. A into a square. I am writing this a square here. So this is a square. A into a. And here is 2i. Divide by 2i. Okay. Next is minus. Minus this one and minus this one. Multiply this minus, then this minus. So minus common. I is and upon a square. Multiply by a into a square. And log sec ax plus tan ax. And in bracket here, what bracket here? E to the power. Minus is common. This minus and this minus. So minus is common. E to the power iax and plus e to the power minus iax upon here only 2. And here 2i. Here is 2i. So this i is cancelled to this. Next third one is this minus this plus and this also minus plus. So third one also plus. So here I 1 upon a square common and sin ax is common. So e to the power iax plus e to the power minus iax upon 2i. So this I cancel to this. So now we get answer here. This is the value formula e to the power iax minus e to the power minus iax upon 2i. This formula is sin ax. Okay. Next formula is e to the power iax and plus e to the power minus iax upon 2 only. This is cos ax formula. Cos ax. So now this result is sin ax and this result is cos ax and this result is cos ax. So we get here solution minus 1 upon a square and multiply here 1 upon a square here. A square, this a square and this a square. This is cancel here. So now this term is cancelled to this one. Okay. We get only here minus cos ax upon a square log sec ax plus tan ax. So this equation number 24. This is the complete PI of equation 24 is complete PI of equation 1. Now complete solution of 1 is y is equal to CF plus PI. So PI is equal to C1 cos ax plus C2 sin ax. This is complementary function. And minus cos ax upon a square log sec ax plus tan ax. This equation completes. This is complete solution of problem 1. Okay. Similarly, we can solve problem 2 based on case 10. Similar. So the CF of equation, this is problem 2. So CF of equation of problem 2. CF of problem 2. is same as problem 1. The complementary function is equal of all 6 problems. So here complementary function CF is same of all 6 problem. All 6 problems. Okay. All problem 6 have same complementary function. All problems have same PI, same CF. So first CF we have already write here, C1 cos AX and plus C2 sin AX. This is CF. We have already discussed in problem 1. Now PI is changed. Because Q is changed, so PI is changed. How we can find PI? So I discuss here. PI is equal to 1 upon FD into Q. So 1 upon FD is D square plus A square into Q is cosec AX. Cosec AX. Okay. Q is here cosec AX. So now PI is equal to, breaking this result, 1 upon D square minus A square. This is cosec AX. This PI equal to 1 upon D square minus, here is I square and A square. I square is minus 1. So here breaking this result, 1 upon D plus IA and into D minus IA into cosec AX. Okay. Breaking this result by partial fraction. Breaking by partial fraction. Here. So this result convert direct to AI and in bracket 1 upon D minus IA and minus D plus IA and into cosec AX. Suppose this is equation 2. Problem is 1. This is equation 2 or 3. We can say equation 3. This is 3 equation. Okay. Now here next multiply by cosec AX 2 in bracket. So this PI is equal to 1 upon 2AI and here multiply this 1 upon D minus AI and into cosec AX and minus 1 upon D plus AI into cosec AX. Okay. So this result and this result, this is equation number 4. This result I am phi 1 writing phi 1. This equal to 1 upon 2 AI. This is phi 1 and this is phi 2. This is equation 5. Where phi 1 is equal to, what is phi 1? Phi 1 is 1 upon D minus IA into cosec AX. This is equation 6. And phi 2 is equal to 1 upon D plus IA into cosec AX. This is equation 7. Okay. This is cosec, this is equation 7. So now solving equation 6. Now solving equation 6. 1 upon D minus IA and into cosec AX equal to phi 1. This equation 6. Now cross multiply here. Cross multiply like this. So here d minus IA into phi 1, this equal to cosec AX. Okay. Multiply by phi 1 to d phi 1 minus IA phi 1 equal to cosec AX. Okay. This is equation 7, 8. This is linear differential equation. D phi 1 upon dx minus IA phi 1 equal to cosec AX. This is equation 8. This is linear differential equation. This is linear differential equation. General linear differential equation is dy dx plus py is equal to q. This is equation 9, comparing 8 and 9. So now here p is minus ia and q is cosec ax and here y is phi 1. So now first of all I am writing IF, integrating factor. This is integrating factor IF. So IF equal to formula e to the power integral p dx. So this is formula e to the power integral p. P is this minus ia dx. So this is e to the power minus IAX. Okay. This is IF, integrating factor IF. So now writing formula y into IF equal to integration q into IF and dx. This is IF, integrating factor. Y is phi 1 e to the power minus IAX. This equal to integration q cosec AX e to the power minus IAX and dx. Now this equal to writing this cosec AX and value of this e to the power minus IAX. This is cos AX minus I sin AX. So this value I am writing here cos AX minus I sin AX and dx. This is value of this. So now here writing cosec AX. What is cosec AX? Cosec AX is 1 upon sin AX. So I am writing here 1 upon sin AX. And here cos AX minus I sin AX dx. So now multiply by this here. This into this. This is cot AX. Cot AX dx and minus I. This multiply by this. Here is this cancel to this. Here only 1 dx because this cancel to this. This multiply to this. This multiply to this. So this cancel here. So integration of cot AX. Cot AX, sin का differential cos. This is log sin AX. Log sin AX, 1 upon a log sin AX. And minus this is IX. So this is phi 1. This is phi 1. Okay. This is equation number. What is equation number? Equation number 10. This is equation 10. Okay. We have complete phi 1 here. This is equation 10. Now we want to find the phi 2. So how we can find phi 2? This is d plus ia and into cosec AX equal to phi 2. Now this upon 1 and cross multiply this. Then we get here d plus phi a d plus ia into phi 2 equal to cosec ax. So now multiply by this d phi 2 and plus ia phi 2 and this equal to cosec ax. Now d is d over dx. So this between d phi 2 upon dx plus ia phi 2 equal to cosec ax. This is linear differential equation. This is equation 11. 11 is a linear differential. This is linear differential equation. This is linear differential equation. Okay. So now general equation is dy dx plus py is equal to q. So p equal to here ia, q equal to here cosec ax and y equal to phi 2. So now first here writing if integrating factor if e की power integral p dx. So e to the power integral p is ia and dx. So this equal to e to the power iax. This is integration. This is integration. So now formula for I here is y into if equal to integration q into if and dx. This is formula. I am writing this is formula. So y into if e to the power iax equal to integration q. Q is cosec ax and into e to the power iax and dx. So now solution of here y is phi 2. Y is phi 2. Putting value of y here, y is phi 2 and if e की power integrating factor e to the power iax equal to cosec ax into this integrating factor dx. So now finally phi 2 e to the power iax equal to integration cosec ax. Cosec ax here 1 upon sin ax. So here is 1 upon sin ax and here integrating factor this e to the power here e to the power iax, value of this cos ax and plus I sin ax. This is the value of this. So this formula we apply here, cos ax plus I sin ax, okay, and dx. So now multiply by this, then we get again here 40x and this cancel to this. So here we get dx and plus integration I into dx. So now here this is log sin ax and 1 upon a and plus ix. This is phi 2 e to the power iax. Dividing by this, then we get phi 2 is equal to 1 upon a log sin ax and into e to the power. This goes to denominator. Then we write here minus iax and plus ix. This here e to the power minus ix. So this is the value of phi 2. This is the value of phi 2 here. Okay. And phi 1. What is phi 1? We have completed here phi 1. Phi 1 is this. Phi 1 is this. Here phi 1 e to the power minus iax. So divide by this. This goes to denominator. Then write in numerator. So we get here phi 1 equal to 1 upon a log sin ax and into e to the power. This minus we write here iax and minus I into x and e to the power IAX. This is phi 1. If in this side is negative, then this side goes to positive. So these value putting in our equation phi 1 and phi 2. Equation, which equation phi 1, phi 2? This equation 3. Equation number this 5. Now here putting value of phi 1 and phi 2 in equation 5. So here Pi is equal to 1 upon 2ai and in bracket phi 1 minus phi 2. This is equation 5. So what is phi 1 here? Pi is equal to 2ai. I am writing here phi 1. Phi 1 is 1 upon a log sin ax e to the power ix. 1 upon a log sin ax into e to the power IAX. Minus goes to positive and minus IX e to the power IAX. Now minus sign here. 1 upon a log sin a. This is value of phi 2. This is phi 1. Log sin ax and minus ix. Here is e to the power sin ax. Here is plus, so here is minus iax and minus ix into e to the power minus iax. So this is phi 1, phi 2 and this is phi 1. Phi 1 minus phi 2. So now final answer is Pi is equal to 1 upon 2ai and here this 1 upon a log sin ax is common. Here is e to the power iax minus e to the power minus iax and here is 2ai. 2. Here is a square and 2 here. 2i. So this is sin ax. And minus this one, minus plus and this minus. So minus taking common here. Here I common, x common and e to the power ix. Minus taking common, so this plus ix and minus e to the power minus ix upon here 2i. So I is cancel here, minus and minus plus. Minus. So here is plus. No, here is plus. So here minus common. Here is plus. This I cancel to this. So this is cos ax. So final answer is Pi is equal to 1 upon a square and log sin ax and here is into cos ax. Sin ax into sin ax and minus x is common, I cancel. So here is cos ax. This is cos ax. This is cos ax. Okay. So this is complete solution of this problem. This is Pi. Final solution is y is equal to Cf plus Pi. So now y is equal to Cf, complementary function, C1 cos ax and plus C2 sin ax and plus this is Pi. Here is also a square, a. 1 upon a here. So here 1 upon a square and log sin ax and minus x upon a cos ax. Cos ax. This is complete solution of the question, this one. Okay. Here complementary function and this particular integral. So now here similarly we can solve this problem. d2y over dx2 plus a square y equal to sin ax. This is problem 3. Problem 3 based on case 10. So you are trying to solve this problem in same procedure. I have solving here 2 problems. similar procedure apply in the question, then you can solve problem 3. So all 6 problem, same procedure apply here, but q is change. Only q, function of q is change. So their calculation is change only. Function in integration is change, but other procedure is not change. Same procedure apply in each 6 problem. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.